Okay, so welcome back everybody. So we're back on task 2 of the moles task sheet. Okay, now calculate the number of moles present in each of the following cases. Okay, so we've got 2.3 grams of sodium, 240 kilograms of carbon dioxide, and 12.5 grams of aluminium hydroxide. Okay, now as we discussed in class, to find moles, okay, of a sample or a compound, what we can do is we can do moles equals mass over mR. Okay, and then we talked about the units, so mole was just mole, units of mass being grams, the units of mR being grams per mole. Now, for those of you who are more mathematically inclined, you can see that we've got moles over here, we've got grams per mole. Okay, so on this side, what would happen? The grams would cancel out, they would cancel each other out, and we'd be left with 1 over inverse mole, and that would give us moles as our unit for moles. Okay, mole. Now, in this particular question, you've been asked to calculate the number of moles. Okay, so sodium. Okay, what is the MR of sodium? Or in this case, it would more technically it would be the AR, the atomic mass. Okay, it's 23 grams per mole. Okay, so all we would do is we would do moles equals the mass that we have, which is 2.3 grams divided by our MR, which is 23 grams per mole. Okay, and we would get an answer of 0.1 moles. Okay, easy as that. Okay, now the second one, slightly trickier. Okay, so first thing you'll notice is that our mass is not given in grams. Okay, so we'll have to convert that. So mass equal to 240 kilograms. Okay, and then we would do 240 times 1,000. Okay, we would times by 1,000 because 1 kilogram has 1,000 grams. Okay, 1 kilogram has 1,000 grams. So to convert from kilograms to grams, we'd have to times by 1,000, and that would give us 240,000 grams. Okay, now from there it should really be smooth sailing. Okay, so MR, atomic mass of carbon is 12, atomic mass of oxygen is 16, but because there's 2 of them, we multiply that by 2, and we should end up with 44 grams per mole. Okay guys, now 44 grams per mole. Okay, so what we're going to do now is find our moles. Moles is equal to mass, so in this case it was 240,000 grams. Okay, all divided by our MR, which was 44 grams per mole, and we would get our answer of 5,454.55 moles to 2 decimal places. Okay guys, now that is that. And the last one, 12.5 grams of aluminium hydroxide. Okay, so the first thing we would do is find the MR of aluminium hydroxide. Okay, So you might notice how I write MR and then I write the compound and then I put the compound in brackets. Okay, it's just a bit of nomenclature in the way that I do it. It's just like something that I picked up over the years. I think it's very good. So it says MR and then you say what are you finding the MR of. Okay, so it's just good practice. Okay, now the MR of aluminium hydroxide. So the atomic mass of the AR, okay, of aluminium is 27. Then we've got this OH group. Now, this would be a good group to commit to memory, okay? So you might want to commit to memory that the atomic mass, well, the molecular mass of an OH is 17. And because we've got two of them, we would multiply 17 by 2. So 17 by 2, okay? And we would get an atomic, well, an MR of 61 grams per mole. Okay, guys? So 61 grams per mole. So moles is equal to mass, which is 12.5 grams, okay, divided by our MR, which in this case is 61, and that would give us 0.20 moles, and again that is to 2 decimal places. Okay, so hope you found this bit useful, and hopefully in class you'll be a bit more confident with finding out the moles. Okay, so it's something that you're going to have to add to your tool belt, your toolkit, your chemist toolkit. Okay, you're going to need this for the next 2 years at least. Okay, now the second part of this task 2 is to calculate the mass. Okay, now we know that moles is equals to mass divided by the MR. Okay, now again, those of you who are more mathematically inclined would have no problem rearranging this to make it mass equals to something. Okay, but some people, as we know, prefer triangles. Okay, equation triangles. Okay, so equation triangle would have mass at the top. Okay, then it would have MR at the bottom, and it would have moles over here. Okay, so that's what we would have. Okay, so if you're not confident with rearranging, what you can do is you can use this triangle. Okay, so in this case we're finding mass, so what I would do, I would take my thumb, put it over mass. Okay, and now what we have is MR times moles. Okay, now let's say for some reason we wanted to find out the MR. I would cover MR, and what we have is mass over moles, which would suggest we would do mass divided by moles. Okay, now if we wanted to find moles, we'd put our finger over moles. Okay, and now we have mass over MR, so mass divided by MR. Okay, so that could be a way to do it. Okay, we could rearrange this to make mass equal to something. We can just do a quick little cross multiplication, and what we would get is mass equals Mr. Oh, I said Mr. I meant MR. Okay, times moles. Okay, guys. So let's move on to the first question. Okay, so firstly, we would want to find out the MR of KBr. Okay, and the MR of KBr is 39.1 plus 79.9, which is equal to 119 grams per mole. Okay. Now what we can do is put down our formula that we've rearranged to make mass the subject of the formula. So mass equals Mr. We'll set it again, MR times mole. Okay, now we've already calculated the MR. We've got the moles. Okay, How do we know the moles? The question has told us we've got 125 moles of potassium bromide. Okay, so all we do now is mass equals 119 grams per mole times the moles, which in this case is 125, and that would give us 14,875 grams. Okay, now we can do the exact same thing with calcium hydroxide. Okay, so I'm going to give you a moment, pause, think about it, pause the video, give these two a go if you haven't already in class. Okay. Okay, so I'll walk through it now. Again, we find the MR first, so the MR of calcium hydroxide. Okay, the MR of calcium hydroxide is 74.1 grams per mole. Okay, now we do the same thing as we did before for potassium bromide. We would times MR, which in this case is 74.1, by the number of moles, which is 0.075. And as a result, we would get 5.56 grams to 2 decimal places. Okay, and again, similar thing for iron oxide here. Okay, we calculate the MR of iron oxide. Okay, now the MR of this is 159.6 grams per mole. Okay, now some of you might be wondering, why have I put grams per mole? Why do I sometimes write it out like this, and why do I write it out like this? Well, neither of them is wrong. Okay, you can write grams per mole like this, or you can write grams per mole like this. You can use them interchangeably, it's not a problem, but in one question you should stick to one. Okay, so for this one I've decided I felt like using this grams per mole, and in that one I've used this one. Okay, this grams per mole. Now in this one I've decided to use this one. Okay, so gram per mole. You can use that if you like. Now mass equals mR times by moles. Okay, and that would give us a value of 39,900 grams. Okay, now the bottom one. Okay, now from the previous two bits of task 2, what we've done is we found the mass and we found the moles. So let's find the relative formula mass, or the MR. Okay, now again we can write out our equation, or we can draw out our triangle. Mass, MR, mole, or what we can do is we can just rearrange our equation. Moles equals mass divided by MR. So to find MR, what we would do is we would do mass divided by moles. Okay guys, that's what we would do. I haven't really drawn this very clearly, so what I will do, I will blow it up and draw it here. Okay, so again, we're finding MR, so we cover up MR, it's just mass over moles. Okay, so again, just a quick run through. Okay, so mR is going to be equal to 88 divided by 0.55, which will give us 160 grams per mole. Okay, so that's our MR. And then again for B, okay, feel free to pause at any moment and go through a question that you haven't done. Okay, so 63 divided by 2.25, okay, and that gives us 28 grams per mole. Okay, and again we would do the same thing. We will do the same thing here. So we would do 0.312 divided by 0.00125, and that will give us 249.6 grams per mole. Okay guys, so hopefully this was helpful. Okay, so I'll give you a bit of time to let it sink in. Okay, hopefully these walkthroughs have been helpful in some way. Okay, hopefully they've cleared up some misconceptions that you may have had in class. And I hope to see you for the next one, for task 3.